Assalamualaikum and hello. My name is Mohamad Nur Aiman bin ZAMZANI. My matrix number B0920100061. Now, our group will discuss about conduction graphical analysis on heat transfer. First, we move to introduction. Conduction refers to when heat energy is transmitted through collisions between neighboring atoms or molecules. Conduction heat transfer is the transfer of heat through matter like solid, liquid or gases without bulk motion of the matter. The heat equation for steady conduction is written as Q equal to negative K times with A times with delta T over delta S, and this equation is known as Fourier's law equation. As we all know, the Fourier's law states that the heat transfer rate through a material is proportional to the negative gradient in the temperature and to the area, at right angles to that gradient through which the heat flow. Next, we move to objective. We have three objectives, which are: first, to perform heat transfer simulation by using any relevant software on fin surface. Second, manage to run the heat transfer simulation. And the last one is recognize the fundamental method to conserving energy when cooling or heating.
Assalamualaikum warahmatullahi wabarakatuh. My name is FIKRI bin NAHAR. My matrix number is B0920100144. And now I'm going to present about the design of our heat sinks. For design number 1, which is the hot fin, we have a heat sink that have 40mm times 40mm base and have 16mm of height, which is the fin height is only 15mm and the thickness of the base is 1mm. The thickness of the fins itself is 1mm and with 1mm gaps between the fins. The fins also have a curved edge with 2mm radius and have 3 5mm holes that bored onto them. This is to ensure the total surface area can be increased. The material that we use to build this heatsink is 6061 alloy, which is aluminium alloy. The mass that we achieve is 0.03366 kilogram, and the volume is 1.25 times 10 to the power of negative 5 meter cubic, and the density that we calculate is 2692.8 kilogram per meter cubic, while the weight is 0.3302 Newton. For the design number 2, we have pointy fins. The pointy fins have 40 triangle fins, which 20 fins each side that have 1mm gap for each 20 fins. The base of the heatsink is 40mm times 40mm and the thickness of the base is 1mm. The fin also have 15mm of height, and the angle between each pointy fins is 7.63 degree. The material that we use on this fin is also the same, which is 6061 alloy, and the mass that we achieve is 0.03591 kilograms, while the volume is 1.33 times 10 the power of negative 5 meter cubic. We calculate the density, which is 2700 kilogram per meter cubic, while the weight is 0.3415 Newton. Thank you.
My name is SHARVEEN, son of ANANDARAJA, and my matrix number is B0920100440. Okay, I'll be presenting the simulation and also analysis part. So we'll start with simulation. As you can see, we took design 1 and design 2 and we ran a simulation on SolidWorks. Okay, so for design 1, the lowest temperature we have got is 79.57 and the highest temperature is 97.59. As for design 2, the lowest temperature is 81.37 and the highest temperature is 98.73. Next, I'll be moving on to the analysis part. I'll be moving on to the analysis part. Okay, to your right is a table. It's a guidance that was given to us to put all the value and run the simulation in a SolidWorks. So the fin paste size is 40 mm times 40 mm. Next is the ambient temperature. We used 30 Celsius and average heat flux on the cold side we have used 1500. As for the convection coefficient, we have used 5.03. So the average expected temperature on the cold side is 76.6 and the average temperature on the hot side is expected around 97.3. So based on our analysis, we made a chart, temperature versus design, and you can see that the lowest and the highest temperature is around the given guidance. So if you analyze this chart, we know that design 1 is better than design 2 because it has a lower temperature on the cold side and lower temperature on the hot side, which is 79.57 and 97.59 respectively. So we can conclude that design 1 is more efficient than design 2 because it's able to dissipate heat better than design 2. And that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Annisa Aishah binti ROZIMAN, metric number B0920104143, and I will continue with the discussion. This fin's entire surface is exposed to a fluid with a temperature of T infinity and a convection heat transfer coefficient of H infinity. Conduction occurs when the solid body of the fin and convection occur between the fin's surface and the fluid surrounding it. A heat sink is designed to have as much surface area in contact with the cooling medium that surrounds it as possible, such as air. Air velocity, material selection, protrusion design, and surface treatment all have an impact on heat sink performance. Heat sinks are important in circuit design because they provide an efficient path for heat to be transferred from electrical devices to the ambient air. As the temperature drops, the length and the surface may increase. When we add more fins, the heat transfer from the surface area increases. The amount of heat transfer is determined by the process driving mechanism and the resistance involved. The maximum heat of the fin is then the ideal situation that is used to evaluate the fin's efficiency. Last, we go to conclusion. The conclusion is we learn about the specification and characteristic of fin surface from this experiment. We learn to choose fin surface based on material, size, and type. A heat sink transfers heat from a device element to the surrounding environment in order to maintain and control thermal energy. We also discovered that the number of fins in a heat sink affected heat dissipation as shown in both designs. Overall, we were able to improve which material is the best heat conductor for the heat sink. That's all from me. Thank you.